Hello everyone, FunshonX here. Welcome to a new series of mine that's going to focus on ComputerCraft. That's right, I'm going back to my roots. I know a lot of people on my channel subscribed, particularly for ComputerCraft, and it's been a very long time since I've done anything with it, other than the Turtle EDU stuff. So, what we're going to do is we are going to build a game that's a little bit popular right now on the web. And while we do it, I would be, kind of going through how I build it and kind of as a tutorial. This will be a very advanced tutorial. This is not going to teach you the basics of ComputerCraft. So if you're watching this and you've never seen ComputerCraft, go check out my tutorial series. But if you want to see more practical uses of ComputerCraft in Minecraft, this will be a great series for you. So, without further ado, you probably already know if you've seen my Twitter account, because I tweeted out a spoiler or a little sneak preview. But we are going to build a game called Keep Talking and Nobody Explodes. I'm going to go to their website real quick. So it's called Keep Talking and Nobody Explodes. It's by a team from Ottawa called Steel Crate Games. They own all rights to the name, images, concepts of the game. I'm simply making a homage to it because I think it's a great game. It's to talk about the game. Basically, you have two players. One player is given a briefcase-shaped bomb. The other player is given instructions on how to defuse different modules. You're not supposed to see each other or see the manual if you're the diffuser, that kind of thing. You're supposed to talk it out. So it can be a party game, or it works well when you're like a remote on Skype or something, playing the game together. But then the concept is that every time you play, the briefcase is completely different. It consists of a timer, and up to 11 different modules that you have to defuse in the amount of time before it explodes. Also, if you try to defuse something and you get it wrong, you get a strike against you. And if you get 3 strikes, the bomb explodes as well. So what we're going to do is we're going to try and build that game, or a version of it, in ComputerCraft. Now, things I'd like to do. Obviously, we're going to have a timer and some kind of explosion. And then I want to build most of the modules that they have in the game, or as close as I can replicate to them in ComputerCraft and Minecraft. But I also want to try and build some of our own modules, things that you could only do in Minecraft, like listen for an animal. If it's a zombie, do this. If it's a pig, do this. Something like that. Play with records in Minecraft. What else could we do? I don't know. There's tons of different things that we could try and create with these modules. So definitely I'm going to need suggestions from the audience here. If you guys have something that would make a really fun debugging module where one person sees the visual and does all the interaction, the other person has, a manual on what to do and you have to communicate, that'd be awesome. So let's get started. Each video, we're going to work on one module. Some modules might be complicated enough to spread across 2 videos. But here is the basic briefcase. I tried to keep it looking very similar to what's in the game. You have kind of these windows with each of the modules, and it's very briefcase shaped. There are occasionally things that appear on the side that you have to look at to help you defuse things, so we'll try and add those in as well. And I want to try and make it random every time. Now, this is going to involve the use of the command computer, which is a ComputerCraft computer that can run command block commands. And I'm hoping it can run copy commands with modded blocks. If anyone knows if that works or not, let me know. Because if it doesn't, we're going to have a problem. But what I hope to do is just build like the module here in this screen, and this will be like the template. And then out somewhere else, I'll have the actual game play area, and it'll randomly, generate and say, okay, I want this module in the 4th slot, and it would put it, in here in the real game. It would just copy from here. That way I can make every game unique and random, can change difficulty, by giving 1 module, 2 modules, or 11 modules, or, the harder modules, that kind of stuff. So that's what I aim to do. We'll see if it works. But yeah, let's get going. So today we're going to work on the timer. Now the timer in the game, I'm going to go ahead and just world edit this little guy out here so that we can have a section to do. Oops, I did not mean to put position 1 there. Try that again. It's been a while since I've used world edit. Set 0. There we go. So we open that up. The timer in the game, probably, let's see. Let's do this again. Let's fill this with, I think it's 159.9. There we go. We'll make it inset, and it consists of a couple readouts. One of them is the actual timer itself. So how big do we want that? Is this going to be too big? You're going to see some pretty cool guys in ComputerCraft today. So there's like our timer. Then it's got a readout of the number of strikes against you, and there can be up to 3 strikes. So I think let's do a panel like that. And then there's a little button here, and I'm not sure if this is like the start thing. So let's just try a button that we'll call start. Maybe we'll have some other method of starting it. Maybe there'll just be a big button right here that says start that you just have to right click on, because advanced monitors can receive mouse input. But then we'll also use this lamp as a indicator that the thing is blown up, because I do not want to put TNT in here until I'm actually playing the game. So yeah, let's just use that indicator. So that'll be my basic readout of the timer panel. Now, the actual timer, I don't want to just draw a message to it because it's going to be too small and it's not going to look cool. So we're going to use a 7-digit display, which is basically like what a digital clock uses. You've probably seen it before. And we're going to output it to this monitor. And so we're going to use APIs because I've written a 7-digit display API in Lua. And then up here, we'll draw our X's. I'm not sure if we'll have to do custom graphics for this or not, or if we could just print an X to the screen. But let's put a computer on here. We're going to need a few modems so we can connect with that guy and that guy. And for right now, I'm actually just going to put the computer right here. That way I can kind of see the effects of my code before. And then later when we're done and we're happy with it, we'll move it into this area. Each of the modules is 7 by 7 by 4 is the max it can be. The inside here will probably all be filled with TNT. So we get a very large explosion if the player screws up. All right, so let's wire those up. And oops, we need another monitor on the computer itself. Shift click, do that, and do that. Now we want to go ahead and right click on each one to turn them on. So we've got computer 1 and monitor 2 and 3. Okay. Let's go into that. I'm also going to need a disk drive. Actually, I lost my disk. The disk that had my API on it is it in my inventory? Let's see. Oh, there it is. Okay. Whew, that was close. I don't need two of those. I got worried there. I have it saved on my machine, obviously, but it's a lot easier to copy paste from a disk than from text. So put this right there. All right, so inside my disk drive, I'm going to put my API disk. This will where I'll store all the APIs I'll use for this. All right, so if we check out the disk, oops, dicks, whatever. On the disk drive, we've got segment API, so we can copy disk segment API to segment API. All right, so now that exists on our main computer. If we want to look at it really quick, it's not too complicated. Oh, I love that they've got type ahead now. We've got one configuration variable. That's basically the size of each segment, number of pixels, I guess. And I kind of alias that to a variable called SL so I can reference it easier than not have to type out segment length. Then I've got segment data, and this is for basically each letter has a certain number of segments. And so 0 has a 1 across the top, or 1 across the top, one on the side, one on the right side, nothing in the middle, one on the left, one on the right, and one on the bottom. So there's 7 segments, obviously, and each of these is basically true, false, draw that segment or not for each number. So 0, 1 through 9. All right. So that's our segment data. Now the segment points, this is basically where to draw the lines. So I give it a location X and a location Y. That's kind of like the top left corner. And then initialize the points into a table based on, so like segment, this you see there's 7 here. So segment 0 is the one across the top. So it starts a little bit indented on the X, it goes straight across the Y, and then goes all the way to the length of the segment. So each of these just defines a line XY coordinates for each of the segments. And then I've got a function called drawDigit. Takes the top left coordinate, the monitor that you want to draw it on, and what digit you want to display. You have to give it 0 through 9 here, it'll throw an error. I should probably check for that, but we'll add error handling later. In ComputerCraft, to draw APIs onto a monitor, you have to redirect to that monitor. So I saved the main terminal, just in case I want to draw on the main terminal. Redirect to the monitor that was passed in. Initialize the segment points based on the location that was given. Alias it's SP, so I can call it easier. And set the default color to gray for the segment. I then do a loop from 1 to 7. And I say if the segment data of the number we want to draw plus 1, so if it's at 0, we go to the first row in this table. And then so that's the data we want to do, and that's the individual segment that we want to do, 1 through 7. If that equals 1, then I set the color to white, otherwise I set it to gray, and then I use the PaintUtils API to draw a line from the X coordinate to the Y coordinate. So a little bit complicated. I'm not going to go through too much on this. I'll probably put it up on Pastebin somewhere if you guys remind me. So that you can investigate it further or improve on it, anything like that. But let's actually use it now. So we'll save out of here and exit. Now we want to get a program, let's just call it timer. So we're going to do edit timer. Let's keep everything lowercase just so it's easier to type. And we'll go ahead and save it. Now what do we want to do in timer? This will be kind of our main computer. Actually, it'll control the entire game. So we're going to have a lot of stuff in here, but for now, let's just deal solely with this one module. So at the top, let's do some good commenting so that we know kind of where things are. So we'll call this the config settings, shreddings. There we go. And what kind of things are we going to want? Well, let's keep a track of the number of strikes they currently have, and we'll default that to 0. Let's keep track of the maximum strikes. And so that means we could change this. We could give them 1 strike or 5 strikes or whatever based on difficulty. Let's set a default like timer. So default diffuse time is equal to, let's 300. That'll be 5 minutes, which is what in the game. And then let's do a the actual diffuse time. And that is equal to default diffuse time. So that's the one that will actually decrement every second. All right, then what else? Other kind of things. We need to know where our monitors are. So this computer has a modem on the back. So let's call it modem side, just so we know, we can keep track of where these things are. And that way if we, excuse me, move where the computer is, we can just edit these 3 variables and be fine. The modem for the strike monitor, which is up top, is called, let's see, it was monitor 2, I believe. And the modem for the timer monitor was called monitor 3. And that's it. Okay. So let's do some initialization or some startup stuff. Here we're going to do, first we want to load that API that we created. So it's called os.loadAPI is the method. And then we pass the name of it, which was segment API. And that'll give us access to any of the public or global methods and variables. Then let's go ahead and initialize the modems. So for the actual modem that's connected to the computer, that's peripheral.wrap, and we're going to call modem side. That's just which side the modem's on. We know it's the back. For the strike monitor, I'm going to call it strike screen. That is going to be peripheral, dot wrap, and now it's modem strike. I'm going to do this last. Same thing for the timer screen. You just tab to autofill in there. Modem timer. Okay, so there's our 3 modems, or monitors, basically. We got 1 monitor and 2 modems. Now let's work on the strike screen first, because that's easiest. So we'll call this strike screen. For this one, let's we'll probably put this into a function later so that we can clear it out whenever we want. But for right now, I'm just going to kind of set them up, initialize, that kind of thing. So we want to do set the background color. And that one's going to be colors.black. Oops. Let's set the text color to colors.red. Let's set the cursor position to 1, 1. Okay, the next thing we need to do is go ahead and like set the font scale to make it as big as we can. And we'll see if that's big enough. If it's not and we have trouble centering it, that kind of thing, then we might have to draw something instead of just writing the font. But let's see, it's set text scale. And the biggest we can go is 5. Let's clear it just in case there was anything on it before. And then we will write out just to test just 3 big X's and see how that looks. Okay, so we can go ahead and save this. Actually, you can now run it right from here, like in debug mode. It's pretty cool. And we screwed up on line 24. Let's find out what we typed wrong. I always have typos here. Strike screen dot set background color colors dot black. Huh. What was the error again? Attempt to index nil. Which would mean strike screen would be nil, which is monitor 2. Is that not right? Oh, that's monitor 3. That's monitor 2. Oh, monitor underscore. That's probably why. That's why. Okay, so it was the modem strike is monitor underscore 3. And see how these variables come in handy? Well, if you need to change them, you can just change them there. It fixes it through the whole code. Now let's try and run it. Oops. Ah, dang it. Try that again. Underscore 3. Underscore 2. Oops. And run it. All right. Do we get 3 big X's? There we go. It's close. I don't really like how it's the font they use. So I'm probably going to change that later to be 3, like just make a straight X. So it looks better. But right now, I think that's okay. Let's go ahead and move into the meat of this, where we're actually going to use the API that I wrote for the 7-digit. That's kind of why I wanted to focus anyway. So this will be our timer screen. All right, and we need to initialize it. So same kind of stuff. Timer screen dot set background color. I need to have just like a function to initialize everything, just past the monitor. That would be pretty good. But we'll update as we go. A lot of times that's what I like to do. I like to kind of just code what I know I need to do and then edit it to make it, simplified, or, if I call the same thing 4 times, obviously need to make a function out of it, that kind of thing. Timer screen, set text color. Oh, let's do colors.white. Oops. And let's do, I want to clear the whole thing, so we'll set the cursor position, cursor pause to 0, 0. Or 1, 1. Sorry, I forget it's a 1-based array. And what else do we need to do? We need to clear it. And before we do, let's set the text scale. Now we want these to look as good as possible, so we want the smallest precision. So we'll do 0.5 for the text scale, and then we clear it. All right. Now we want to start drawing on the screen. And again, this will be wrapped into a function, but just to test our API, let's say, let's do a loop. And remember, we're using a variable called diffuse time that starts at 300. So while diffuse time is greater than 0, do a loop. All right, and inside this loop, we will say, we're going to clear out the screen every time. So I guess I need to clear it above, but that's okay. Timer screen dot set background color. Always do that before you clear, just in case somebody else has messed with your background color. Otherwise you get weird results. All right, and that'll be our clear. Now we need to figure out how many minutes, how many seconds, so we know each digit. So let's say minutes is equal to diffuse time divided by 60. That'll say our 300 divided by 60 is 5. Once it goes to 299, it'll get us 4. But with Lua, when you do this division operator, even though it's on an integer, it's going to give you, 4.999 or something. So we need to actually call math.floor on this, and this will give us a whole number. So it'll be 5, then it'll go to 4, 3, 2, 1, 0. Our seconds are going to be diffuse time modulus 60. Remember, that gives you the remainder. So 300 divided by 60 is 5 with 0 remainder, so we'll get 500. Once we get to 299, it'll give us a 4, and the remainder will be 59. So that gives us what we want for seconds. However, we need to break those down into the tens place and the ones place. So let's do another variable here called seconds tens. And that's going to be, again, the math.floor of seconds divided by 10. That'll give us the tens digit, and then we'll need the ones digit, so the local seconds ones, and that's just seconds modulus 10. All right, so we should be good. That'll give us the different things. Now we need to actually call our API. So remember, we called it segment API, and it's auto-filling for us, which is cool. And first we need to provide the location. So let's indent a little bit, like 30. Then we'll have our the starting Y. Let's do close to the top, like 5. The monitor that we're going to is called timer screen, and the digit that we want to pass is our minutes variable. All right, that'll print that. Same thing. Let's scoot it over a little bit, like 65, timer screen, seconds tens, and then same thing, 95, timer screen, seconds, ones. All we need to do then is tell it to sleep for a second, and then decrement diffuse time. Save that and give it a run. Let's see how it's doing. Okay, we're a little bit off on our location. That's fine. But it looks like it's working. It looks better from far away. And so you can see if it's whatever the number is, it knows where to put the segment. And if it is on, it turns it white. If not, it turns it gray. Cool. All right, and it's counting down. Perfect. It won't be exactly 1 second all the time, but it's going to be close enough. And the game actually, as you get more strikes, counts down quicker. So we don't really have to be super accurate. Control T to quit because we're in infinite loop. And let's move, let's see. Should we do, I don't know, let's move it to like 10. And then like 40, 70. That's getting better. I'm wondering if I should leave this one here, but move these guys over maybe like 3 more digits. Let's do that. Or 3 more pixels. So let's do like 43, 73. That'll give us some separation. It's still quite not quite there. So maybe, I don't know, I'll just play with it. All right, that looks pretty good. We might play with the colors, maybe do it red. Oh, let's do it red. And the cool thing about that is I can just edit it here, save and exit this program, edit segment API, oops, edit, you have to hit tab and then hit enter. And then we can come down here, and I might make this a variable up top so I can change it if I want, but let's try it red. And then let's run timer. There we go. It's a little more visible. Cool. And remember, this monitor, this disk drive will be gone, so it'll look a lot cleaner. And actually, now that we're pretty much done to it, let's just save a copy. So let's Control T, and let's do copy timer to disk timer, and copy segment API to disk segment API. Oops. Forgot you have to delete first. Seriously? Access denied. Let's try that again. Oh. Okay, whatever. I'm still getting used to this autofill. All right, copy. There we go. So now we can take that disk, which has our programs on it, get rid of this. This is labeled, so we should get it back. Yep, we do. We can fill this in. Come up top, and now we can move it right here. We'll need to put a modem there, and we'll need to get the name of this. This is still computer 1. Okay. So the only thing we'll need to change in our program is that this is now on the left. If I get top. Let's see if it still works. It does. There we go. Cool. Well, guys, that's going to do it for our first module. We've got our 7-segment display, and our timer is running. We've got initial indicators for the number of strikes. And next time, I think we'll work on the push button. That's a button that's going to be have a different color. It's going to be have a different word on it, and depending on what it says and what color it is, and some other factors, you do different things to the button. So hope you guys enjoyed this episode. If you did, hit that like button. Make sure you subscribe to my channel so you can see more episodes of Keep Talking and Nobody Explodes. Make sure you go check out their website, buy the game if it looks interesting to you, and have fun playing it. This has been FunctionX. I'll catch you guys later. Bye.